Perfect. All is in the screen, right? It's in the
Yes,
right
sir.
on the screen.
Yes, sir.
Oh, wonderful. All right, so let me tackle number 1. Now, the first 4 are going to be self-explanatory. The first 4 I'm going to explain them, and then the rest we're going on not do as much working, but you're required to do all the working, okay? So the first one, x squared minus 7x minus 18. A is 1, B is minus 7, and C is minus 18. A by C is 1 by minus 18, which is minus 18. And I'm looking for the pairs of factors of minus 18. So if I remember correctly, when we list in the pairs of factors of a negative number, we list in all the pairs of factors with the repeats. And I just put in minuses in front of all of the numbers, right? One of the number. So for example, I'll leave a space. I'll have 1 and 18. Then I'll have 2 and 9. Then I'll have 3 and 6. 4 nothing, 5 nothing. Then I'll have 6 and 3. Then I'll have 9 and 2. And then I'll have 18 and 1. And we say just slap a minus sign in front of all of the numbers. And you could go to your calculator and see which one of these, when I add them, I'm going to get minus 7. And you're going to realize minus 9 and minus 2 will be the pair of factors you have to pick. So I replace in minus 7x with minus 9x plus 2x minus 18, x into x minus 9 plus 2 into x minus 9, x minus 9 into x plus 2. And we're done. Now, if you put the 2x first, let me see what we're going to get now. We'll do the variations for them. If you had x squared plus 2x minus 9x minus 18, x into x plus 2 minus 9 into x plus 2, we end up with the same thing. Cool? So it doesn't matter which one you put first, we are going to end up with the exact same thing. All right, number 2. P squared minus 5p minus 14. A is 1, B is minus 5, and C is minus 14. A by C is 1 multiplied by minus 14, which is minus 14. Again, I have the, after list the pairs of factors of a negative number, I'll list all the factors with repeats. So 114, 27, 7 and 2, 14 and 1. Slap a minus sign in front of all of them. Plug them in a calculator as an addition process. So you're adding each of these factors. You realize minus 7 and 2 is going to be the pair. So you end up with p squared minus 7p plus 2p minus 14. P into p minus 7 plus 2 into p minus 7. P minus 7 into p plus 2. Yeah? Nice. Now, 3 and 4 will be similar to 1 and 2, right? Very, very, very similar to 1 and 2. So I just pick in the answers, 3 and 4. You'll get m minus 1 into m minus 8 for number 3. Did you all get that for number 3?
Yes,
and for number 4, you get x minus 9 into x minus 7.
Yep, that's correct, sir.
Good. So let me tackle number 5. Number 5 is a little bit different. 7x squared minus 31x minus 20. Oh, some big numbers, right? A by C is 7 by minus 20, and I get minus 140. Yeah? Now, this is where the dilemma occurs. Minus 140 have plenty pairs of factors. Plenty. Yeah? It have a lot. My job now, I want to try and make my life easy and don't write down all of them. I just looking for the pair that will add to give me negative 31. So if you want, very, very easy. You can just go into your calculator and you can check, right? I know for sure, across, I know for sure 1 and negative 140 not gonna be the one. Yeah. So I'm gonna check 140 divided by 2. 2 and 70. One of them have to be a minus. One of them have to be a minus for sure. Yeah, because I'm looking for the factors of minus 140. So minus 2 plus 70, not going to work. Minus 70 plus 2, not going to work. 140 divided by 3, I don't get a whole number. 140 divided by 4, I get 35. Looking kind of ish, yeah? 4 and 35. So let me write it down now. 4 and 35, and 35 and 4. Putting a minus sign in front of everything, you go realize minus 35 and 4, when I add them, I'll get minus 31. Now, if you list out all the pairs of factors, no problem, right? But you didn't have to. If you're comfortable listing all of them to find it, big up yourself. Now, I'm going to put the numbers in such a way that it's easy to factorize. So when you're looking easy, I have the negative 35 comes first. 7x squared minus 35x plus 4x minus 20. I get 7x into x minus 5 plus 4 into x minus 5. X minus 5 into 7x plus 4. Yeah?
Yes, sir.
I mean, if you put the 4x first, you'll get a different answer. But once you use the negative 35 and the positive 4, you're good to go. Number 6 looking a little tricky as well. Number 6 looking a little wonky. 7k squared plus 9k. Now, just because I'm not seeing c doesn't mean it's not there. I could put a plus 0 and have c to be equal to 0. Agreed? So a will be 7, b will be 9, and c will be 0. Agreed? A by c is 7 by 0, which is 0. Yeah? Pairs of factors of 0, I have an infinite number of them. Anything by 0 is going to be 0. Can you all agree on that? Yeah? Make sense?
Yes, I just kind of messed up that one, sir.
So my pairs of factors of 0, it could be 1 and 0, 2 and 0, 3 and 0, 4 and 0. But which pair is going to add to give me 9? 9 and 0.
Yeah.
Agreed? So 9 and 0 is going to be the pairs of factors I'm going to replace. So I end up with 7k squared plus 9k plus 0k plus 0. All agree with that?
Yes, sir.
All right. So I end up with k into 7k plus 9 plus 0 into, remember, this bracket and this bracket have to be the same thing. Yeah? They have to be the exact same thing in order for me to factorize one step further. So, because this is 0 on the outside here, brother man, I can put anything inside. I could put anything I want inside the bracket. So I will put something inside that will suit my factorization process. I'll put the 7k plus 9. 7k plus 9 into k plus 0. And I don't even have to write the plus 0 because it has no value. 7k plus 9 into k. Now watch this. Shortcut. K and, well, I'm going to put the k plus 0. That is 7k plus 9, right? Shortcut. Whenever you have a quadratic and it does not have the value of c, meaning c is equal to 0, you could factorize it normally. Remember when we did normal factorization? I could factorize this normally as long as there's no c. Factorizing this normally k is common in both terms, and I remain with 7k plus 9. Okay? So only if there's an absence of c, or if the value of c is equal to 0, then I can factorize a quadratic using regular factorization. Pulling out the common term, dividing each of the terms by that common term to figure out what's going inside the brackets. Do you all understand that?
Yes, sir.
Nice. Now, number 7, 8, 9, 10, all of these will now be repeats of questions we have already done. It's just a rinse and repeat process. The hardest thing will be to find the pairs of factors. Okay, so let's go through the answers and you guys tell me which ones you didn't get, and let's see if we could fix it. For number 7, 7x plus 4 into x minus 7. Tell me yes or no. Once everybody is good, once nobody says no, then I'll move on to the next one, okay? Number 8, 2b plus 3 into b plus 7.
Yes, sir.
Number 9, 5p plus 9 into p minus 2. I seen Dylan shaking his head.
That one I kind of mess up.
All right. 5p squared minus p minus 18. A is 5, b is minus 1, and the c is minus 18. 5 by minus 18 is equal to 5 by minus 18 is minus 90. Yeah? I'm looking for a pair that kind of close to each other because I want to get minus 1. So I'll pick the pair 10 and 9. Agreed?
Yes, sir.
I had to repeat the factors because there's a negative number I'm dealing with. A minus here and a minus here. Which one will add to give me minus 1? I most believe minus 10 and 9 will add to give me minus 1. So I'll get 5p squared minus 10p plus 9p minus 18. 5p into p minus 2 plus 9 into p minus 2. P minus 2 into 5p plus 9. Where was your mistake, Dylan?
You pairs of factors.
Which one you use?
These minus 9 and 10.
Ah,
That's what I get wrong, yeah.
all you have to do is make sure you check it on your calculator, right? Simple, just check it on your calculator. See if it adds to give you minus 1. Orlando, did you see where your mistake was?
Yes, sir.
Good. Number 10 was a bit of pressure. All right. Now, in number 10, I will say, all right. So let me explain what they did in what you have to do in number 10, right? Number 10 doesn't look like a quadratic. Agreed? It doesn't. It looks like a regular factorization process I can do. Yeah. So I have to perform a factorization process first, then get the quadratic. All right. So, shucks. So for number 10, we had 28 n to the power 4 plus 16 n cubed minus 80 n squared. I realize n is common in each of the terms. So I put the n on the outside. Yeah. I also realize 4 is common in each of the terms. The lowest power of n was 2. You all remember this, right? Regular factorization. In my bracket now, I'm going to get 28 n to the 4 over 4n squared, and that look like 7n squared plus 4n minus 20. Tell me if you all seeing that. So inside of number 10, inside of this, there was a quadratic hide up somewhere. We do some working and we get the quadratic that was hide up. Cool. And we're given all comfortable with the factorization, this should be very easy to factorize. When you factorize this, you'll get 4n squared multiplied by whatever you get when you factorize, which worked out to be 7n minus 10 into n plus 2. So your only work now is to factorize 7n squared plus 4n minus 20. All right. Number 11, you would do the same thing. I'll factor out b, and then I'll end up with a quadratic inside. Number 12 is our straightforward factorization. Did you all get this for number 12? 7x plus 10 into x minus 6.
For me, no, sir.
All right, we work it out. 7x squared minus 32x minus 60. I'll just multiply the pairs of factors multiply the numbers one time, right? We have 7 by 60 minus 420, right? So let me start to look for a pair of factors. 420 divided by what we could work with. 20. 20, nah, that I go up, right? 420 divided by 30. That looking so as well. 420 divided by 14. Nah. 420 divided by what boy? What we go get here? Aha. 420 divided by 10. So the hardest thing now is to find these pairs of factors, right? 420 divided by 10 is 42. All right, so it's looking like 42 and 10 and 42 with a minus sign attached in front of one of them. And the only way you will get these things, fellas, is if you practice. All right, it's your eye figuring out which ones to use is by practice. You're not gonna get big numbers like this for CXC at all. CXC gonna be so easy. Minus 42 and 10 is going to be the pair. Did you get that pair, Orlando?
Yes, sir.
Nice. So 7x squared minus 42x plus 10x minus 60. 7x into x minus 6 plus 10 into x minus 6. X minus 6 into 7x plus 10. Which number did you put first, Orlando? When you substitute the pairs of factors.
For the same order you have it, sir.
Okay. You see where your mistake was?
Yes, kind of, sir. I put a plus before the 60.
All right, so you'll end up in problems then. Number 13 was the same thing as number 11 and number 10, where we have to factor out something first, and then we get the quadratic in big brackets, then factorize the quadratic. I have a question now. Why is number 14 not factorable? And why is number 16 not factorable? Tell me why. Why is this not factorable? Just remember, in order to factorize something, we need to follow certain criteria. Certain conditions must be satisfied, right? I had to find something when we factorize in quadratic. We had to find something. We had to find the factors, find the pairs of factors that add to give me B. Yeah, that have to happen before I can factorize, because I need a replacement for B. I need to split up B in a smart way, and that smart way is by using the pairs of factors. I'll agree with that.
Yes,
But
sir.
if you look at the pairs of factors of negative 90, none of them will add up to give me minus 5. None of them. Once that happens, the quadratic cannot be factorized. All right, cannot be factorized. The same thing will happen for number 16. I will never find a pair of factors that will add up to give me 7. Never. Number 17 is the same approach as number 13 and such, where you factor out something first and you get your quadratic. Did you all get m plus 9 into 10m minus 1 for number 18?
For me, I switched it, sir.
Where again?
I just put the 10m minus 1 first and the m plus 9 after.
That is no problem, right? That is zero problem at all. So we have two critical thinking questions, right? For what values of b is the expression factorable? What did you all get for number 19? And if you could understand number 19, you could actually make up a quadratic that you can factorize on your own. So watch. Tell me if you agree with me here, right? X squared plus bx plus 12. A by c is 1 by 12, which is 12. I'll agree with that. Factors of 12. 1 and 12. 2 and 6. 3 and 4. Minus 1 minus 12. Minus 2 minus 6. Minus 3 minus 4. Yeah? All of these here, I can add and get a sum of them. 13 minus 13. 8 minus 8. 7 and minus 7. Agreed? These numbers here are the sum of the pairs of factors. Yeah? I'm going back to the first one we did. I listed all the sum of pairs of factors and I just picked one that added to give me b. Yeah? For number 1, let me see. All right. I'm going back down here. For number 12, let me say b was 8. And I go pick 2 and 6 as the pair of factors. If b was 8, and I go pick 2 and 6 to break up the 8. Sorry, yeah, if b was 8. I don't know why I get, yeah, if b was 8. If b was 13, and I go pick 1 and 12 to break it up. If b was minus 13, and I would pick minus 1 and minus 12. If b was negative 8, and I would pick minus 2 and minus 6 to split it up. So b could take the form of any one of the sum of the pairs of factors of a by c. Any one of them. And we could potentially make up a quadratic. So let's try and make up a quadratic here now. If I have 4x squared plus something x plus 1. What could be a potential number that goes here to make this factorable? Tell me. Any ideas, Dylan? All right, look, Dylan, now say something here. Dylan, say 4. Explain how you get 4, Dylan.
Well, you would have pairs of factors where you could get 4x, where when you do the whole bracket, you will get 4x and you will get plus 1.
All understand what you say there? Me understand one thing you say.
Yes, I don't understand either.
You lost me there, boy, Dylan, boy. Tyrese, you understand what the man said there? But you're shaking your head, yes. Jump on the bandwagon. Try again, Dylan. Try again. How you gonna explain that to me? No, you're correct. How are you explaining it to me? All right, Tyrese, you go get a chance just now. I see you raising your hand there. You go get a chance just now, right? All right, Tyrese, jump in. Jump in, Tyrese, jump in. This man looking like he hurting himself. You was raising your arm. You spell raising wrong. Come on, help me. What could be a number that goes there to make this quadratic factorable? All right, let me help you with this one. I'll go kill the next one, right? And A by C could be 4 by 1, which is 4. The factors of 4, 1 and 4, 2 and 2, minus 1 and minus 4, minus 2 and minus 2. Correct? So the sum here is 5, sum here is 4, sum here is minus 5, sum here is minus 4. Yeah? If I had 5x here, and I go through my factorization process, and I'm going to replace 5x with 1x and 4x. That is where the 5 come from, by here. And if this was now 4, and I'm going to replace 4 with 2x plus 2x, that is where the 4 comes from. If here was minus 5, and I'm going to replace minus 5 with minus 1 and minus 4. And if it was minus 4, and I'm going to replace it with minus 2 and minus 2. Yeah? So when we calculate the sum of the pairs of factors, these are all the possible values of B. B in any quadratic, I could only write down one value for B in a quadratic. So it had to be one of the pair of factors. Agreed? You all understand what I'm saying?
Yes, sir.
So tell me what could be potential values for B. 4x squared and then something x plus or minus, right? Now let me use 4. Let me use 5 and plus 2. Give me some possible values for x.
So we could try 11.
10 and 1, correct?
Yes, sir.
Right, I see some of you say 7. That would be 5 and 2. Yeah? What else? Follow suit from the one before. We have 2 more. Where's the other 2? Very good. Minus 7 and minus 11. Yeah? Because I could have minus 5 and minus 2 being a pair of factors of 10. And minus 10 and minus 1 being a pair of factors of 10. Yeah? All right, let's look at the last one. Similar. Name 4 values of B which make the expression factorable. X squared minus 3x plus B. So A by C in this one here, right? So follow with my if other thing, right? We call it good. A by C is 1 by In this case, C has a value of B, which is B, 1B. Yeah? Cool. So I am looking for pairs of factors that could add to give me -3. Yeah? Because that's all looking for things that could add to give me -3. Correct? So what can add to give me -3 here? Well, it have plenty answers to this, fellas. If I have -5 and 2, and that will add to give me -3, and it will multiply to give me -10. Correct?
Yes, sir.
Remember, all your pairs of factors will add to give B and will multiply to give A by C. Cool? So 5 by 2, when I multiply it, I'm going to get -10. Yeah? So I'm looking for this multiplied by this, supposed to give me -10. Yeah? 1 multiplied by B, supposed to give me -10. Agreed? Because that is A by C. Well, if 1 by B is -10, B will be -10 because I divided by 1. Correct? Our next pair of factors that could add to give me -3 will be -6 and 3. Yeah? When I multiply them, I get -18. So again, 1 by B is supposed to be -18 and B will be -18. So as long as you could figure out what -3 is in terms of an addition, then you're getting values for B. -100 plus 97. Yeah? When you multiply them, you'll get the value of B. You'll understand that. Well, you'll never get a question like number 20. You might get something like number 19 for exams, but never something like number 20. So your homework is to do up the ones that you didn't do. All right? The ones like number 9, where you had to factor out something first. Yeah? What we are going to do next week. Next week, we're going to dive into solving each and every one of these quadratics. It's just one step more. Just one additional step, right? It's a simple step, but it's a step that could lead to a little more working. All right? That's what we're going to learn next week. Anybody have any questions on factorizing quadratics? Everyone is okay? Yeah? All right.
Yes, sir.
I'll stop the recording.